We're going to be evaluating limits using properties of limits and evaluating limits basically using algebra. So the first thing that we will say is that if a function is continuous at c, so at x equals c, that basically means that there's no hole and there's no asymptote or any kind of break in the graph. So if it's continuous at c, then you can evaluate the limit by using direct substitution, meaning that we take that c value and we just plug it in for x into the function. That's really the easiest way to find a limit. So if it's continuous, that's pretty convenient for us. A few basic things about limits here. If you're taking the limit as x approaches any number c of a constant function, so just a number, then that limit will always equal whatever that constant is. Second thing, if you're taking the limit of just x as x approaches c, then that limit is just c. And if you're taking the limit as x approaches c of x to the n, that limit will be c to the n. So whatever c is, it's just c to the n. Examples here. First one, we're taking the limit as x approaches 4 of x cubed. That would just be 4 cubed, which is 64. The limit as x approaches 4 of 23, so that's a constant. That limit would just be 23. And then the last one, the limit as x approaches 7 of x is just 7. All right, so that's as basic as limits will get for us for the most part. Okay, so here we have some properties of limits that we need to point out before we start. So let b and c be real numbers, let n be a positive integer, and let f and g be functions with the following limits. So the limit as x approaches c of f of x is capital L, and the limit as x approaches c of g of x is capital K. All right, so the first rule is the scalar multiple rule. So if you have the limit as x approaches c of a real number b times f of x, then that limit is equal to whatever b is times the limit of f of x. Sum or difference rule, if you're adding two functions together, you can just add the two limits together or subtract. Product rule, same idea. If you're multiplying two functions together, you can multiply their two limits together, and that is perfectly okay. Quotient rule, same idea. If you're dividing two functions, then you can divide the two limits, given that k cannot equal 0. So the limit of the function in the denominator can't equal 0. That gives us a different problem. Power rule, again, same idea. If you have a function and it's raised to a power, then you can take the limit of that function and raise it to whatever the power is. So we just have to state these going forward. We've got some examples here. Let the limit as x approaches c of f of x equal p. The limit as x approaches c of g of x equals j. And the limit as x approaches c of h of x equals 5. Okay, so the limit as x approaches c, first example of f of x plus g of x, so this would be the sum rule. We know the limit of f of x is p, the limit of g of x is j, so that means the limit of the two of them added together is just p plus j. All right, next example, the limit as x approaches c of h of x cubed. We know that the limit of h of x is 5. So that means the limit of h of x cubed is 5 cubed, which is 125. And then last example here, the limit as x approaches c of f of x of g of x divided by h of x is just j divided by 5, going with the same logic as the others. All right, limits of trig functions, everyone's favorite thing. The limits of trig functions work the same way as normal functions. Typically, they can just be solved by direct substitution and by using limit properties. All right, so first one, the limit as x approaches 0 of tan of x. So what we'll do is we'll plug in 0 for x there, and we know, hopefully, that tangent of 0 is 0, so that means this limit is also 0. Now with a function like this, hopefully you know that this has vertical asymptotes on it, so you do need to be careful that whatever value you're plugging in has a real answer. Otherwise, the limit doesn't exist. All right, so number 2, the limit as x approaches pi of x times cosine of x. Again, we'll just plug in pi for x into this. So we get pi times cosine of pi, which is pi times -1, which is negative pi. And then last one, the limit as x approaches 0 of sine squared of x. We'll just plug in 0 for x. Sine of 0 squared is just 0. And we'll point out that for cosine and sine, if you know what those graphs look like, you should know that those are continuous everywhere. So it doesn't really matter whatever x value we're approaching, we can just plug it in for x.